I am Justin Ivy, and this is my protocol presentation of the internet. So, I'm going to be going through three types of um, internet protocols in this presentation: internet protocol, IP support protocols, and IP routing protocols. So, that's what I'm doing. IP support protocols. So, what is IP? It's what we refer to as internet protocol. It's a protocol or kind of like a set of rules for routing and then addressing packets of data so they can travel across the network and arrive at certain destinations, like the correct destinations. Um, as you can see in this photo that I have, this is our basic life of devices that we use, kind of like in our everyday life. Most of us have a router that either transmit through wireless connection or wired connection. Um, so I remember DSL, which was me sitting on the computer waiting for it to connect forever, and it took over your phone line. You couldn't use a phone. Now we have several devices receiving network connection through our laptops, our printers, our desktops, gaming systems, phones, Alexa, what have you. IP packet. So we connect through what's called the IP packet, and the IP address is kind of unique identifier that is assigned to a device or like a domain that connects to the internet. So each IP address is a series of characters, and they translate human readable domains into IP addresses because users aren't able to access websites without memorizing the complex series of characters, so it eliminates that. Each IP packet will contain both the IP address of the device and the domain sending the packet, and the IP address of the intended recipient. So that is it. It's like a piece of mail, kind of like you have the destination address and the return address all on the piece of mail. Okay, so IPv4 versus IPv6. So it's basically the fourth version of IP is IPv4. It was reduced. It was introduced in 1981. Um, However, there's just only so many possible permutations for automobile license plate. It's the same thing. It had to be reformed periodically. So the supply of the available IPv4 addresses has kind of become depleted. You can't use any more. So IPv6 addresses have many more characters, so you can have more permutations with characters in it. Where IPv6 is intended to eventually replace IPv4. They are kind of tightly mingled now, so most engineers just run both. Um, IPv6 offers these improvements over IPv4, which would be it's more efficient routing without fragment packets. It's built into quality of service. It that distinguishes delay sensitive packets. It eliminates of NAT to extended addresses spaced from 32 bits to 128 bits, I think. Yeah, 128 bits. And also the network layer security is built in. It's stateless address auto configuration for easier network administration. And it also improved header structure with less processing overhead. And IPv6 was deployed in 1999. So using IPv, how it kind of related to me, it was through gaming. So I have an Xbox One, so that's the example that I decided to use. Um, so if you want to enjoy the best possible gaming experience, it doesn't have to be an Xbox One. It can be a PS4, PS5, what have you, PC. Uh, you should use IPv6. The Xbox One, it natively just supports IPv6, but finding an ISP that will give you IPv6 connection to the internet is kind of difficult. By using the IPv6 on your console, you should have less latency when playing multiplayer games, which is a really big deal. Any data that you transmit over the internet should be safer and more private. In general, any connections made to your device, either remote servers or peer to peer, should be faster and way more responsive, which I have found to be a great difference. So, IPNAT, basically, NAT allows a single device like a router to act as an agent between the internet or like a public network and a local network or private network, which kind of means that only a single unique IP address is required to represent to an entire group of computers to anything outside their network. Okay, so NAT is designed for IP address conversation. They talk to each other. Enables private IP networks that use unregistered IP addresses to connect to the internet. So NAT operates on a router, usually connecting two networks together, and it translates in private uh, addresses in the internal network into legal addresses before packets are forwarded to another network. So basically, as a part of this capability, NAT can be configured to advertise only one address for the entire network to the outside world. This kind of provides like additional security by effectively hiding the entire internal network behind that address. So NAT offers that dual function for security and address conversation and is implemented in remote access environments. Okay, so I just say IPsec. It's way easier to remember. It stands for Internet Protocol, and SEC is for secure. So it's a secured Internet protocol. The Internet protocol is the main routing protocol used on the Internet. It designated where data will go using an IP address. So IPsec is secure because it adds encryption to it and authenticates to this process. So IPsec is a group of protocols that are used together to set up encrypted connections between devices. It helps keep data sent over public networks secure. It's also often used to set up VPNs, and it works by encrypting IP packets along with authenticating the source where the packets came from, which is very helpful. Okay, mobile IP, um, Internet Protocol. It enables the transfer of information to and from mobile computers, which is your mobile device, uh, such as laptops and wireless communications. The mobile computer can change its location to a foreign network and still access and communicate with and through the mobile computer's home network, which is very nice. All right. So, Internet Control Message Protocol is an error reporting protocol network. Uh, Device like routers can use to generate error messages to a source IP address when the network problems prevent delivery of IP packets. So, Internet Control Message Protocol creates and sends messages to the source IP address indicating that the gateway to the internet to that router, service, or host cannot be reached for packet delivery. any IP network device that has capability to send, receive, and process ICMP messages. So ICMP is not a transport protocol that sends data between systems. While ICMP is not used regularly in an end user application, it is used by the network administrator to troubleshoot internet connections and diagnostic utilities, including ping and traceroute. Next slide. So the IPv6 neighbor discovery process uses ICMP messages and solicit node multicast addresses to determine the link layer address of the neighbor on the same network. So it's a local network, and it's verified the reachability of the network, of the neighbor, and track neighboring devices, which is pretty cool. Next slide. IP routing protocols. All right, IP routing protocols. This is a pretty big one. So routing protocols are effectively distributed database systems. They propagate information about the telepathy of the network among the routers within the network. Each router in the network then uses the distributed database to determine the best loop, free path through the network to reach any given destination. So there's two ways to distribute the data through the network by distributing vectors and distributing the state of the link. So there's link state protocols as well that rely on each router in the network to advertise the state of each of their links to every other router within the local routing domain. So your distance vector, routers running distance vectors advertise the vector, the path, the distance metric usually for each destination reachable within the network to adjacent peers. And path vector protocol does not rely on the cost of reaching a given destination to determine whether the path available in the loop is free or not. Instead, the path vector protocol relies on analysis of the path to reach the destination to learn if the loop is free. Next slide. So, Border Gateway Protocol is the postal service of the internet. When someone drops a letter in a mailbox, the postal service processes that piece of mail and chooses the fastest, most efficient route to deliver the letter to its recipient. It's the same thing. It makes the internet work. It does it by enabling data routing on the internet. Let's go down to hijacking. So hijacking BGP. Sorry, I'm kind of getting close to my time. Sometimes BGP hijacking is not accidental. These routers best destination for all traffic on the internet. So as these routers spread further and further to more anonymous system, a massive disruption occurs, creating a crisis where people across the world are not able to access some of the internet. External gateway protocol is used to exchange net reachability information between the internet gateways belonging to the same or different anonymous system. So EGP was the first exterior gateway protocol that gained widespread acceptance in the internet. The routing table is stable with minimal changes to the protocol. It does not react to issues with anonymous systems. It's a simple reachability protocol. And unlike modern distance vector and path vector protocols, it's limited to tree-like topologies and does not support pathway network environments, making it less efficient. All right, the IGRP. It uses IP directly using protocol number 9. RIP uses UDP port 520. It uses numbers to distinguish between routing domains and its classified routing protocols. Operation of IGRP will only send routing updates to routers that are within the same anonymous system. There are 3 types of routers. It's interior routers, system routers, and exterior routers. Interior routers, the routers are subnet that are locally connected. System routers are summarized networks with a AS and exterior routers and the networks outside of the AS and are called default networks. So the Hello protocol is responsible for establishing and maintaining neighbor relationships and also ensures that communication between the neighbors are bidirectional. On multi-access networks, the Hello protocol elects a designated router for the network, along with other things. The designated router controls the adjacencies will be formed over the network. And the gate-to-gate protocol, GGP, is an obsolete protocol defined for routing datagrams between internet gateways. The gate-to-gate protocol was designed as an internet protocol datagram service similar to TCP and UDP, but it was classified as a internet layer protocol. And GGP uses a minimal hop algorithm in which measures the distance of the router hops. So a router is defined to be 0 hops from directly connected networks, 1 hop from the networks that are reachable through one other gateway. The protocol implements a distributed short path methodology. So it finds that shortest path to do that. So this has been my presentation. Thank you very much.